Okay, so the next problem in the lead code we are solving is path sum. Okay, here we have given the binary tree and also one target sum. Okay, what we need to do here is we need to first check the paths. Okay, like among different paths, like the paths here is nothing but 5 to 7, 5 to 2, 5 to 13, and 5 to 1. Correct. All these are a path, and if we take a sum of those paths, right, we'll get one value, right? For each we'll get a value, and if any of those values matches with the target sum or not, that is a thing that we need to do. If it is matches, we'll need to return true, else we'll have to return the false. Okay, so this is the problem, and this problem will be very much useful, easy, like when we know how to build a paths actually. Okay, so how we are going to build a path, let me just give a summarize. Okay, so how we are actually making it work. So let's say that how the building path works is, let's say that we are on a 5. Okay, and we need to build a path, right? Like ultimately when I'm here, so I should be knowing that I've traversed from 5, 4, 11 and 2. Okay, similarly here 5, 4, 11, 7 this time, right? This is the path building, right? We need to, the leaf node should know how it traversed. Okay, so now how to do it? Okay, so how we can do it is, let's say that initially we are at 5. Okay, we are at 5, and when I'm going to 4, I need to send 5 to this one because I've built this path so far, right? I know we have traversed 5, so we'll be adding the 5. And when we are going to this node, we need to tell this node that we have traversed already in this path 5, 4. Okay, similarly, when I'm asking this node, I should be sending 5, 4, 11. I have traversed the 5, 4, 11 node. Actually this will be easy to understand when you assume this as a ABC. Actually A, B, C, D. Okay, it's like whenever we are building the path, right, this will be more clear. So when I go to this node, I will tell that I have built I will traverse A node already. So when this node talks with this node, it will say that A and B, I have traversed A and B. Okay, similarly when I'm finally here, this node will get an information that it has already traversed the ABC node, and whatever the current node is D, I will append it to it, and finally the final path will be ABCD. Right, this is how this is how we build the paths, right, in the tree. So now let's see that how we can make use of that to here. Okay, so let's say that these are like initial conditions. Let's say that if there is nothing in the root, we'll just return a false, right? It's not at all we can do any calculation, we'll be returning a false. Okay, and let's say that where are we taking the sum? We are not taking a sum here, right? Like I mean we are taking a sum, but we are not comparing it with the result, right? We are going to compare, we'll consider a path only when this is the path, right? Root to the leaf node, that is the path. So we'll be doing the final calculation only in the leaf node. So this is where we are checking if the root node, if whatever the node we are checking, if it is a leaf node or not. If it is a leaf node, we already know that we traverse from 5, 4, 11. So the current sum says that it will have that value. What are the sum that is calculated so far? We'll add two more to it and find the answer to it. Find the answer, like okay, if it is a will done some this and it is matching to the target sum. Okay, yeah, this is the sum that we are expecting, will be returning the true. Okay, and yeah, once again let me take a simple example to explain this. Okay, let's break down this problem. Okay, let me clear this out. Okay, so let's take an example. Let's take only one node as an example. Okay, we have been given only one node, which is 5. Okay, but the current term, what will be the current sum when we start? Current sum will be 0, and let's assume target sum is equal to 6 this time. Okay, so when we enter, let's quickly check. This itself is a leaf node because we don't have any child there. This itself is will be the leaf node. Current sum will be 0 at that time, and we'll be adding 5 to it. 0 plus 5 will be 5, and but what we wanted is 6. So in that case, we'll be returning the false. Okay, but let's say that if the target sum is equal to 5, what would have happened? It will be resulting into the true. We'll be returning it as a true, and that will be the right answer. Correct, like with 5 is the given node and the target sum is also given node, that will be the answer. Now let's try to expand our problem. Okay, so now what we need to do is, let's assume this problem. Okay, let's take this part, let's forget of the rest. Okay, so now what we need to do here is, we are asked to check if there are any paths which result in that sum of 13. Okay, we need to find if there is any path that will result in a 13. Okay, so how we're going to do, we don't have only one node here, right? We need to do check in the left also, right also. So it's like recursion again. Okay, so I will ask this guy. Okay, let's forget about the recursion also now. So I will ask this guy here to find if you get the sum of 13 or not. Okay, so when I'm doing it, I will send whatever the sum that is done so far. Okay, I know that 0 plus 5 was calculated, and it will be 5. Okay, and similarly I will also tell this guy to let me know if you find any path with the sum is equal to target sum is 13. Okay, so now what will this guy do is, so again as we discussed, right, whenever we get a leaf node, we need to check the we need to add the value to the current sum and check with the target sum, right? 4 is the current value, and this is a, we identified that this is a leaf node because it does not have any child. Let's forget about this one. Okay, so we don't have a child, yes, correct. So 4 plus 5 is 9. Okay, 9, is it matching with the target sum? No, this is not the answer. Okay, so the left tree will return back to the root saying that I didn't find any path that matches with the target, so that will return a false. So now what will happen, I have also this root node, I have also asked the right tree to get me the answer. Okay, so what this will guy will do, again let's forget about these child nodes. So what it will happen here, 8, this is the left tree and this is the right tree. There is nothing, so this we identified this as a leaf node. So root has sent me that 5 is the current sum done so far. So what this leaf node will do, 8 plus 5, as this is a leaf node, we are doing the final calculation. 8 plus 5 is equal to 13. Yes, we found an answer. This is the okay, I found the target sum path. So what it will do is it will return back to the main node, like I mean a root, saying that okay, I found it. So it will return a status as true. So if you just see here, this tree returned as a false, this tree returned as a true. So ultimately we just want to identify, like, if there is any one of the paths, right? I will just return right path or left path. If any one of them has written as true, I will be returning the answer. So this is how the problem works. This is like, I mean, currently we saw in the analogy of example of one node and also two node. The same thing will happen for the any number of node. Let's say this was not a leaf node, right? Again, this will ask this guy to find out an answer for me. So what this guy will send, 5 plus 4. He will send that I have done a calculation so far till 9. Please check further and let me know. Okay, similarly when this happens, you will ask this guy whatever the done calculation done so far, right? That will be that will happen here. Okay, whenever he is going to send it, so he will say that 5 plus 4 is 9, 9 plus 11 is 20, right? He will tell that I have done the calculation so far, it is 20. Tell me, like, take this further from here. Again, he will ask this guy also. Like, I've done the calculation so far for 20. Tell me if you find any paths. Okay, so when we finally reach the leaf node, what we are going to do, okay, it's a leaf node, so what we'll have to do, whatever the calculation done so far is 20 and plus 2, so it will be resulting into 22, right? So okay, this matches the target sum, so I will tell the parent node that with the status true, this guy will return 27, so I will return as false. I didn't find any sum, bro, like it's like that. Okay, so it's ultimately uh, one of the root node, one of this child node return a true, so this guy will consider it as a true because we are interested in either one of them, like we don't want every path to be equal to the target sum, either of one of them. So you will consider that okay, he found it. Okay, like he will consider it as a true, and he will tell the same to this guy, so that okay, we found it, like I mean true, he will send ultimately tell this guy. And finally, he got an answer true from here, correct? From the left tree he got an answer true. From this might be either true or false, we don't care, one is true, so ultimately we'll be returning the answer as true. So this is how it is working. If you just analyze the code, it will be more clear. And I think if you know already how to build a pass, right, then it's a kind of straightforward thing, right? The current sum node value, we'll be asking the left tree to do the checksum, and we'll be asking the left tree. Ultimately we'll see, like, either of them return true, right? We'll be returning the status. If both are false, false. If both are returned true, also, like, that's also valid one. Yeah, either one of them is also true, that's also valid one. That's it. Yeah, thanks.